An indifferent curve can be defined as the locus of various combinations of quantities of two goods, each of which offers the same level of satisfaction. Each point on the curve indicates that a consumer is indifferent between the two, and all points give them the same utility. The indifferent curves possess certain characteristics which are also called as properties. Number 1. Convex to the origin. Number 2. Negative slope. Number 3. Directly proportional level of satisfaction. Number 4. Never intersects each other. Number 5. Asymptotic to the axis. For example, a man might be indifferent between possessing 1 coffee and 3 bread or 4 coffee and 1 bread. So both of these combination would be points on an indifferent curves of the man.
By the term itself, this approach makes use of graphs as aid for analysis. To understand the approach better, the following assumptions are set. First, consumers given a choice of basket of goods with only 2 desirable products or goods. Basket of goods refers to a fixed set of consumer products and services whose price is evaluated on a regular basis. Next, the 2 goods are preferred by the consumer. The goods are choice basket reflecting the combination of goods available for the consumer. However, to simplify the analysis, we limit it to just 2 goods. Besides, only 2-dimensional graphs will be used later for the graphical presentation of the 2 axes, x and y, to represent the given 2 desirable goods. The third one is the goods are not perfect substitute for one another. Insights concerning indifferent curve concepts can be gained by considering what indifferent curves look like for the goods that are perfect substitutes since they satisfy the same need or desire. To understand the indifferent curve concept of goods that is not perfect substitute, we can consider inciting the indifferent curves look like for the goods that are perfect substitute to one another. And lastly, the goods are given up at the expense of another. The giving up here means that the number of combination of goods for consumption follows the rule that if you want to increase the consumption of the number of units of the goods, you have to combine one with other goods at a lesser number of units. In other words, the ratio of goods to another goods should not be the same or equal. In this last assumption states that the goods should not be equal or the same to another goods.
About some examples of indifferent curves approach. Peter has 1 unit of food and 12 units of clothing. Now, we ask Peter how many units of clothing is he willing to give up in exchange for an additional unit of food so that his level of satisfaction remains unchanged. Peter agrees to give up 6 units of clothing for an additional unit of food. Hence, we have 2 combinations of food and clothing giving equal satisfaction to Peter as follows. Situation number 1. 1 unit of food and 12 units of clothing. It states that the combination of 1 unit of food is equivalent to 12 units of clothing. Meaning,
if he has 1 unit of food, it is equivalent to 12 units of clothing that he may trade to Peter.
Number 2. 2 units of food and 6 units of clothing. On the example, Peter has 1 unit of food and 12 units of clothing. But we ask if how many clothing units is he willing to give up just for this food unit. And now, he's willing to give up 6 units of clothing just for the 1 unit of food. And by asking him similar question, here are the tables. And below it, there is the graph.
What is the marginal rates of substitution? The marginal rates of substitution is the name given to this population exchange. The marginal rates of substitution is the number of units of one goods that a customer is prepared to forego in exchange for units of another goods while remaining equally satisfied. The substitution does not imply a preference for one goods over another, but rather that the customer is prepared to give up units of one good in exchange for more units of another. The formula of MRS XY, the marginal rates of substitution between both goods. Derivative X, the change in good X, the number of units a consumer is willing to give up. Derivative Y, the change in good Y, the number of units a consumer gain by giving up units of good X. Let's take the famous actress Hardy Evangelista Escudera as an example. We all know that she works for a fashion industry. She loves to collect shoes, bags, accessories, clothes, and other fashion items. One day she goes to a mall and shops for bags and shoes. Now there is a sale for bags and not in the shoes. This causes problem to her. She needs to decide how much bag would she give up in exchange for shoes and still get the same satisfaction. That change of products is called the MRS.
An indifference map is a set of indifference curve that represents the level of satisfaction of the consumers.
This thing here, this is what we call the indifference map. And there's three indifference curves, which is IC1, IC2, and IC3. The IC1 will give you a satisfaction, but it is the lower one. Then IC2 is the middle, will give in satisfaction also. IC3 is the greater one. Now we can see here, there's point A, point B, point C, D, E, F, and G. On this indifference map, we can see that there's a table of food and clothing. On IC1, there's point A and point B. Point A have 2 foods and 6 clothing. Now, on point B, in order to get another 4 foods, we have to give up 4 clothes. So, B, 6 foods, 2 clothing. And then, C have 4 food and 8 clothing. D, 8 food, 4 clothing. Now, if we can see there on a difference map, let's compare the point A and point C. Now, both of them, they will give different satisfaction because A is located on IC1 and then C is located on IC2. But here, we can see that there's point A and point B. They have different numbers, but still, they can give the same satisfaction because they're both on IC1.
4 essential properties of indifference curves. So, the first essential property of indifference curve is that a higher indifference curve indicates a higher level of satisfaction as compared to a lower indifference curve. So, I have here an illustration for you to better understand it. So, there are 3 indifference curves, and it is the IC1, IC2, IC3. This is the indifference curve that I am referring to. So, as what I've said, the IC3 has the highest level of satisfaction, and the IC1 has the lowest level of satisfaction because the higher the indifference curve is, the higher the level of satisfaction it has, while the lower the indifference curve is, the lower the level of satisfaction it has.
Number 2, indifferent curves never intersect each other. It says that 2 ICs can never touch each other. In addition, they must be parallel to one another. So here's an example. A and B lie on ICI. They give similar satisfaction to a different individual, while their A and C also give some satisfaction as they lie on IC2.
The indifferent curve is represented as the downward slope right. This is due to the fact that if a consumer raises his or her consumption of one item, he or she must sacrifice units of the ordered commodity in order to retain the same level of happiness. It is the greater quantity of both items.
An indifference curve is always convex to the origin. The slope of an indifference curve shows the rate that the consumers are willing to trade off goods and services. An indifference curve is a convex to the origin because when the consumer begins to increase the use of one good to another, the curve serves as the marginal rate of substitution. The marginal rate of substitution goes down as the consumer gives up one good to another. So it is a convex of origin.
A budget constraint represents all the possible combinations of consumption of goods and services that a consumer may purchase given the current prices within his or her given income. So I have a graph here in where the budget line shows all the possible combinations of the two goods that the consumer can buy within the funds available to him at the given prices of the goods. All combinations that are within his reach lie on the budget line. So that in this graph, the point outside the line that I'm referring to is this is the budget line, and the point outside of it represents all of the combination beyond the financial reach of the consumer. On the other hand, the point that is inside the line or inside the budget line represents underspending by the consumer. So if this graph has many points, all of the points that are outside the budget line represents combination beyond the financial reach of the consumer, while the points that are inside of the line or the budget line represents underspending by the consumer.
Budget set. It is the collection of bundles of the two goods that a consumer can buy with his income at the market's prices. Here is the equation of the budget set. X1 is the unit for the particular good. X2 is the unit for the another good. P1 is the unit for the price of the particular good. P2 is the unit price for the another good, while M is the consumer's income. Price of the particular good plus price of the another good should be less than or equal than the consumer's income. For example, I have a 500 pesos and I want to buy goods. Then the price of the particular good plus the price of the another good should be less than or equal than my 500 pesos. In that way, I will be able to buy the two goods that I want.
Budget line is also known as budget constraint. In economics, it represents all the combinations of goods and services that a consumer may purchase given current price within his or her income. Budget equation is M is equal to PX times X plus PY times Y, whereas PX is the price of good X and X is good X, and PY is the price of good Y and Y is good Y, and lastly, M is equal to the income. For example, our PX is 10, our PY is 5, and our M is 50. Going back to our equation, M is equal to PX times X plus PY times Y. Therefore, our budget equation here is 10X plus 5Y is equal to 50. We measure good X on horizontal axis while good Y on vertical axis. For example, Casey is a consumer whose income is 500 pesos. She often buys yogurt which costs 50 pesos per box and tuna sandwich which costs 25 pesos per piece. In this case, assuming that all of Casey's income is consumed to buy a yogurt. To get the quantity of the yogurt bought, we have to divide the income to the price of the yogurt. So that is 500 pesos divided by 50 pesos. We have 10 boxes. On the other hand, if we assume that the income is fully consumed to buy a tuna sandwich, we have to divide the income 500 pesos to the price of tuna sandwich, which is 25 pesos per piece. So therefore, 500 divided by 25 is equal to 20 pieces. By connecting these two intercepts, we can get our budget line, which indicates that the consumer can purchase any combination along or within this line. So which means that along or within this line is affordable for them. Otherwise, anything beyond this line is not affordable for this type of consumer. Questions: what if the price changes and what if the income changes? In these cases, the budget line will move inwards or outwards. If the price increase, the budget line will move inwards, while if the price decrease, the budget line will move outwards. Same as the changes in our income. If the income decrease, our budget line will go inwards, while if it increase, our budget line will go outwards. Why? Because the budget line depends on the income or budget that we will consume and price that we will purchase.
Now let's proceed in making our graphical representation. We have here our x-axis that contains the quantity of good x and y-axis that represents the quantity of good y. This can also be called the vertical intercepts and horizontal intercepts. These intercepts represents the maximum number of goods that consumers can afford. We have here our formula. To get the horizontal intercept, we have to divide income to our px, and to get vertical intercept, we have to divide income to our py. So we have here our examples. Px is equals to 10, py is equals to 5, and income equals to 50. In getting our horizontal intercept, we have to divide 50 to 10. 50 divided by 10 equals to 5. So our horizontal intercept is 5. 1, 2, 3, 4, 5. Let's draw a dot here. And to get our vertical intercept, we have to divide 50 to our py, which is 5. 50 divided by 5 equals to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's draw a dot here. Then, let's connect them. This is what we call budget line. Let's proceed to our another example. We have here px is equals to 50, py is equals to 25, and income is equals to 1,250. To get our horizontal intercept, we have to divide 1 to 50 divided by 50. That is 25. So our horizontal intercept is 25. 5, 10, 15, 20, 25. Let's draw a line here. To get our vertical intercept, we have to divide 1 to 50 to our py, which is 25. That is 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Let's draw another line here. This line is what we call budget line.